I recently made this 17-pound copper tube to experiment with Lenz's law using this terrifyingly powerful neodymium magnet. It's fascinating to watch this magnet seemingly defy gravity while it floats to the bottom of the tube. This happens because as the magnet moves, it creates electric currents in the copper, which in turn create magnetic fields that oppose the magnet's motion. This invisible resistance slows the fall, making it look like the magnet is defying gravity. What's even more fascinating is that when I place the magnet in the tube and spin it, the magnet stays suspended in the center. This got me thinking, will a spherical magnet float in the center of a copper sphere? Well, in today's video, we're going to find out. But first, I need to make a copper sphere that we can actually see into. I wasn't sure how I was going to go about designing something like this until I noticed one of my dog's favorite toys. Here's what I designed. It's as close as I could get to a sphere while still being able to see the magnet through it. This shape is actually called a truncated icosahedron, but that's a mouthful, so for my sanity, I'll just refer to it as a sphere. I started by 3D printing it in PLA plastic. I'll use these 3D prints to make a mold out of ceramic shell. It came off the printer looking pretty good, but I still needed to spend some time cleaning it up to get it ready for casting. Next, I'll attach some sprues. These are what I'll pour the metal into, and they're really large because they'll act as risers, supplying the castings with molten metal as they solidify and shrink. Here's the ceramic slurry that I use. Over the course of about a week, I'll dip the models into the slurry a total of 9 times in order to build up a thick shell. In between each layer, I'll coat them with fused silica sand. This helps thicken the shells and also adds some strength. Making complex shapes like these is where casting in ceramic shell really shines. There's no way I could make these any other way, and having a machine shop make them would be incredibly expensive. Next, it's into the kiln to burn away the plastic and turn the shells into a strong ceramic. I don't just burn away all the plastic though. Once the temperature is high enough for it to liquefy, I remove most of it, and then I return the shells to the kiln and fire them at about 1600 degrees Fahrenheit. Here's all the copper I'll be melting. This is 9 pounds, or about 4 kilograms. It's mostly copper pipe with some wire thrown in there also. It'll take about an hour to melt this amount. Copper is always fun to melt because it creates these really cool looking green flames when I add fresh pieces to the crucible. Once the copper's hot enough to pour into the shells, I'll quickly remove the shells from the kiln while they're still extremely hot, place them on some sand to catch any spills, and then pour in the metal. It's always amazing to me that for all the prep work and time that I put into thinking about this, figuring out how to execute it properly without fumbling around or making any mistakes, it only takes a few seconds or so to cast these and they're done. It's out of my hands. I've done this hundreds of times by now, but I still get a little rush of adrenaline every time I pour a casting, and I think that's mainly because of how much work has led up to this point, and I just want everything to go right, and fortunately, most of the time it does. Now I just have to wait for them to completely cool overnight before I can start removing the shells. I'll have to use my sandblaster to carefully remove the shell because I can't risk trying to break it off since copper is so soft. I could end up deforming the castings in the process. This is actually really satisfying. Instead of just slowly blasting the whole thing away, I try to cut large pieces off. To give you some idea, each shell took about 30 minutes to remove. These castings turned out super nice looking. You can see these booger looking things here, which are caused by air bubbles as I dip the models into the slurry. These are really easy to remove with a chisel though, and besides that, they're just about perfect. Now I'm drilling a hole into the center while I have something to hold onto in the vise. It'll make it easier to file in the pentagonal shapes later on, and you'll see what I mean in a minute. I wonder what I could use these for. Any ideas? It's really important that these pentagonal holes are filed straight and precise, as I'll be 3D printing plugs to fit perfectly into them. These plugs will serve as points where I'll be able to spin the sphere, so the fit needs to be exact for smooth and balanced rotation. The last step is to polish each facet, and this little belt grinder really made it easy. I'm using a Scotch-Brite-like belt, which can polish each facet in just a few seconds. Since it's solid copper though, it heats up really quickly, so I have to cool it down in between each one. Well, here it is. I think this thing turned out incredibly cool looking. Honestly, even if I had just made it as something cool to look at, I'd still be really happy. Okay, let's find out if it actually works. Here are the plugs that I'll press into the holes I filed in. Hopefully they'll stay put. To hold the sphere together, I printed some clips, which should do the trick. The magnet I'm using is a 2-inch N52 neodymium magnet. It's the most powerful grade you can buy as far as I know. And of course, I also made a stand for everything to sit on. Okay, so I've resisted actually spinning this thing up until this moment, so hopefully something cool happens. Oh yeah, it is. It's actually floating right there, look. There, and now it's kind of falling, but at the right speed, right there. Yep, that's so cool. I wonder if I can get a better angle on this so you can see what I mean. Okay, so I changed up the lighting a little bit, and obviously it's a different angle, so hopefully you can see what I'm seeing. Yeah, it is actually floating there. It's just about getting the right speed. Right there. Yep. It's totally just floating there. That's awesome. Oh man, that's so cool. Let's try a drill. So I think when I do it really, really fast, centripetal force is just forcing it over to one side, I think. So obviously this is working, but it's difficult to get it at a consistent speed. And also this plug isn't fitting in there really well. I think it's kind of worked itself loose. So I'm gonna need to reprint this, and then in the future, maybe I'll hook it up to a motor, and that'll make it a lot more consistent.
So clearly it works, but the effect isn't quite as dramatic as I was hoping for. There may be some ways I can improve on it, so let me know if you have any ideas. Besides levitating a magnet, there are a whole lot of other things I can do with this thing. By using another magnet about a foot away, I can rotate the whole sphere. It's really hard to show on camera just how strange it is to manipulate the magnet in here. It's almost like it's underwater. It's very bizarre. Let me know if you can think of some experiments I should try, and I'll make a compilation video. If you would like to follow along with the progress of my projects and help to support the channel, then consider joining my Patreon for Patreon-only content. I hope you enjoyed the video, and if you did, let me know what you think in the comments, give the video a thumbs up, and subscribe for future projects. Well, thanks for watching, and I'll see you in the next one.